Good morning. My name is Emily Reniker, currently a graduate student in education at Morningside, and I also teach third grade at a school on the east side of Iowa. My study is titled The Impact of Sharing Strategies to Solve Basic Math Facts on Automaticity and Fluency in a Whole Group Setting. So what's the problem? A report in 2008 from the National Mathematics Advisory Panel indicated that children in this country cannot solve single-digit addition, subtraction, multiplication, or division problems as quickly or efficiently as students from other countries. Another report from the National Center for Educational Statistics found that only 39% of fourth graders and 32% of eighth graders are proficient in math, meaning over half of students in fourth and eighth grade are not proficient. This is a problem for me because when I teach math, many students arriving to me in third grade are struggling with basic addition and subtraction facts. Multiplication is a big idea in third grade, and when they struggle with these basic skills, they're also struggling with other complex concepts like fractions. In reviewing the literature, students are employing more time focused on computing math facts and solving advanced problems that require more complex thinking. It's holding students back from being successful in other critical areas of math, and they're lacking these basic math skills such as facts and number sense. And when they're getting into these harder classes like that deal with fractions or algebra, they're really struggling. The theoretical framework that is the basis of my study comes from Piaget and his theory of constructivism. So his theory states that students are able to construct new knowledge based on their prior knowledge. And his theory is rooted in how children learn, and he came up with 4 stages of cognitive development. He has some underlining assumptions of these stages of development that support my study. The most important one is his assumption on how children construct their own worldview and how children adapt to the environment around him. Past research really focuses on explicit teaching and systematic delivery. Several of the interventions that I noted in my study follow direct instruction and rote memorization. They're based on small group or one-on-one, and most of them provide immediate feedback. That is a similarity to my study, that immediate feedback, but most of these studies that I'll touch on focus on rote memorization, and the students are by themselves like one-on-one, or it's in a small group setting where the teacher's delivering that explicit instruction. Some examples of this past research include a cover, copy, compare method where the student sees the problem written down with the answer, they cover it, they copy it, they answer it, and then they compare the two to see if they're correct. Another one that is more well known is taped problems, where students have a worksheet in front of them of math problems. They are listening to a recording and they're trying to beat the tape. So they're writing down the answers. When the tape gets to the answer, if they're wrong, they have time to correct it and then move on to the next one. The gap in research is important because I've found few or no studies that focus on a whole group setting, so more like a tier 1 intervention, and I didn't read anything on that research that focused on students sharing strategies among themselves in class, and very few studies that are focusing on reasoning and relational thinking in order to master their basic facts. A lot of the studies were a lot of skill and drill and memorization. Will sharing strategies in a whole group setting have a positive impact on student mastery of basic math facts? The purpose of this study was to investigate the impact of students sharing strategies with peers and building on prior knowledge they already have to increase fluency and automaticity of basic facts. So again, this study could serve as tier 1. It could help students improve basic facts by using strategies, reasoning, and relational thinking, and help keep up with their typically developing peers by utilizing them as a tool. So for my methods, this was an experimental research design. A pretest was used before instruction began, and averages were taken on a weekly basis. Participants. So the school that I work in is in an urban area in a city of about 60,000 people downtown. The students were 2 third grade classrooms. One classroom was a group, the other classroom was a group, and this school has about 265 pre-K through 5th grade students. Of those students, 98% of them receive free and reduced lunch. 34 total students made up these 3rd grade classrooms. 11 of them girls, 23 of them boys. The population at my school is diverse. We have Caucasian students, African American students, and Marshallese students. 6 students are entitled for special education in the areas of reading, writing, math, and behavior. And the Dibble screener was used to place students into classrooms. So the Dibble screener was the reading test before FAST came out for most schools. The materials that I used was an HP Pro laptop, a smartboard on the wall that also came with a projector, the document camera that I used to place the flashcards underneath that were projected on the smartboard. I bought these basic addition and subtraction flashcards at the Dollar Tree. A digital timer was used primarily for the assessment. Everyone got 2 minutes, so the timer ensured everyone got the same amount of time. We used it on a daily basis to make sure we didn't go over our 10 minutes. Procedure. So both groups practice facts for 10 minutes daily. One group with the treatment or the instruction, one without. Both groups took a 2-minute weekly assessment of 25 mixed addition and subtraction problems. And then the percent that they got correct was recorded each week when I collected data. So the treatment for the experimental group, most important parts of it were that they got partners and they used sentence stems to help promote their communication with their peer, their partner. And then, so then when they use the sentence stems, that's when they were sharing their strategy and their thinking. So they had time, the flashcard was under the document camera projected on the board, and the students had a few seconds to think about the answer for themselves. They talked with their partner, they shared their strategies, and then the teacher would call on a pair of students to share their strategy with the class. So not only were they talking with a partner, but then the rest of the class was hearing from a pair of students on how they solved their problem. And you will see the sentence stems here. So this is a place for them to start. A lot of students started their sentences differently, but for those students that weren't sure how to start, we taught them these first. For the data analysis, I used an independent samples t-test, and again, that baseline was given before instruction started. The results. The hypothesis was not confirmed. The t-value of 28, negative 1.708, and the p-value was 0.09. What I noticed after I was analyzing my data was that I had statistically significant means at the time of the baseline. So you'll see that on the next slide. It was important because the means on the baseline showed me that these two groups were drastically different in regards to their skill level. So essentially I was comparing apples to oranges. So I should have used a paired samples dependent t-test, and that way if I would have run that test, the experimental group would have been compared to themselves where they started, where they finished, and then the control group would have been compared to themselves where they started, where they finished. In Table 1, Group 1 is the experimental group, and you can see that they started out at 50.75. That was their average score on the baseline. And Group 2 is the control group, and they started at 72.80. That was their average, correct? So you can see how significant those two scores are, and that right away both groups were in completely different places in regards to their ability to solve facts. And you can see the means on the post-test, though, given this test that I ran, that the experimental group, Group 1, really caught up, and Group 2 did not quite make the same growth. Group 1 made 29.78 points growth from start to finish, and Group 2 made 18.13 points growth. However, Group 2's means remained much higher the whole time. On this next figure, Group 1 is this darker color gray, and Group 2, the control group, is the lighter gray. So you can see on the baseline again that those standard deviations are very high. And Group 1, the experimental group, their standard deviation was much higher, so that tells me that a lot of students in class, their scores were all over the place. On the post-test, you can see that the standard deviations are much smaller and closer to the mean. So what does this all mean when we interpret it? Experimental group made growth, although not statistically significant with this test that I ran. The control group scores remained high from start to finish. Past interventions are showing more success in terms of statistics. Some limitations. Attendance. Because of the population that I work with, I have a lot of students that are not good attenders. And sometimes when students are attending, they were not participating fully. So some suggestions for future research could be running data with the kids that attended consistently and employing maybe a survey, seeing which students want to participate and will participate every day in the instruction. Some other things that impeded the learning in class besides attendance, if they weren't there at school at all, was sometimes behavior impeded learning, not only for the student themselves, but their behavior affected other students' behavior. So again, making sure students are ready to participate and are ready to be at school, or maybe just running the data on those students who were there consistently. I mentioned earlier that students were placed by reading scores with the DIBELS test, and that determined class sizes. So the experimental group had a higher number of special education students entitled for reading, writing, and math than the control group. So that could have been a reason why the hypothesis was not confirmed. A suggestion for future research could be using a math screener to group students for classes, or just to group them for the purpose of the research. And maybe having a little bit more of a balanced groups could work, especially if an independent t-test was used again. Otherwise, using the dependent paired t-test would work if groups are not quite as equal. The population of participants that I worked with are at an at-risk school. They come with limited home support and limited background knowledge. So, as well as the number of special education students that are at our school are higher than other schools. Allowing more time for the intervention could be a possible suggestion for future research and a possible limitation on this study. They only practice for 10 minutes a day, so possibly increasing that time might serve as a positive impact on future research. Or the duration, this study lasted for 6 weeks, so possibly extending that into a longer period of time, or following a group of students for more than 1 year to see if the basis of this research would have a positive impact on their learning. So although my study or the hypothesis was not confirmed, there was enough data to implicate the following. So teachers could use this as a tier 1 intervention for students who have not mastered their facts. It meets a variety of students in class. So students that already know their facts are going to be a valuable tool to help students that don't know their facts. And as I mentioned, with kids that are poor attenders, a lot of them might not know their basic facts because of home life or because of lack of exposure to teaching at school, and they don't have a disability, so they don't need that explicit instruction or one-on-one. They might just need more exposure to higher order thinking from their peers. For students, again, they get to stay in the whole group setting. It promotes communication and collaboration, and they're not being pulled out into a smaller group. And here are my references that I learned from and supported my study. Thank you.